Okay. Today we're going to talk about, or tonight, 6-5 point float form and writing linear equations, day 1. So, our objectives for the day: students will use point float form to graph equations. Given a point and slope of line, will write equations in point slope form. Given 2 points, students will write an equation in point slope form. So far, we have studied slope-intercept form, which is y equals mx plus b, where m is the slope and b is the y-intercept, and standard form, ax plus by equals c. Now, we're going to talk about point slope form, where we have y minus y1, where y1 is a point, or a y-coordinate of a point, and equals m times x minus x1, where x sub 1 is also a point. So, m is the slope and x1, y1 is a point on the line. So if this is true, we would just make sure we put the x-coordinate where I've highlighted in yellow, the y-coordinate where I've highlighted in y sub 1 or highlighted in yellow, and then the slope would go in the spot for m. So if we are to graph y equals, or y minus 7 equals 3 parentheses x minus 5, let's keep in mind, I'll write right above it. Oops, and I guess I put the slope in there. But the point 5 matches up with the x1, that's why it's right here. And 7 matches up with the y1, which is right there. Be careful, even though it's listed first, the y-coordinate, remember, is the second part of an ordered pair. So first we would plot the point 5, 7 on our graph. And then we're going to use the rise over run of 3 to get a second point. So I go up 3 over 1. Gives me my second point. So I'll fill in my first point a little bit darker. And then you'd want to use a ruler or straight edge to connect those points to form our line. Next, what I'd like you to do is look in your textbook at page 337 and just take a minute to read through example 1. You probably want to press pause on this video before you move on to do that. Okay, welcome back. You would have seen something similar to this equation in example 1. We are now going to graph y minus 2 equals 1/3 parentheses x minus 1. So once again, I'm just going to write the point slope form below here so we remember what each of these things stand for. Alright, so if you notice, x minus x sub 1 is matching up with x minus 1, so that would make the x-coordinate 1. And y minus 2 is matching up with y minus y sub 1, so that would make the x-coordinate 2. And we have an m value of 1/3. So notice on the graph, the first thing you see is the point 1, 2. Then we're going to use the slope, which is a rise of 1 over 3, to move up 1 and to the right 3. Finally, finally, again, I'm going to connect those 2 points with a line. Okay. Why don't you, again, if you want to just press pause and try this one on your own, and then you can start up again after you've graphed it. Or if you're not quite sure what to do with the x plus 2, you could just go ahead and listen to my explanation. If I look at this as the same thing as before, y minus y sub 1 equals negative 2/3 x minus x sub 1. I know I put the slope in there again. But I noticed that this is y minus 5, which means my y coordinate is 5. However, this is not x minus 2. And it might be helpful for you to think of this as x minus a negative 2, because x minus a negative 2 would be of the form x minus x1. So, since x minus negative 2 is the same as x plus 2, what that means is our x coordinate is actually negative 2 here, rather than positive 2. And our y coordinate is still 5, which gives us the point negative 2, 5. So I'm going to plot the point negative 2, 5. Sorry about that. Why that keeps coming up. Okay. And then I'm going to take my slope of negative 2/3 and go down to the right 3, which would put me at the point, you'll notice here, 1, 2. And then I'm going to take my straight edge and connect those with a line. So once again, that was the point negative 2, 5, which was right here. And if I went down to over 3, hold on, 1, 2, oh, I made a mistake, didn't I? Down to over 1, 2, 3, my fault. Okay, so that was, it should actually go through those 2 points right there. Okay. I can use my eraser to erase my other line. So we were going down to negative 2, 1, 2, 3, 4, 5, and then down to the right, 1, 2, 3. So I'm going to erase this one. Okay. Here. And just because I want to, I'm going to put this arrow back on. Alright, so that would be the graph of that line. Alright, now, we've just been graphing things in point-slope form. To write an equation in point-slope form, you need 2 things. You would need a point and a slope. And let's say I gave you 2 points, if given 2 points, you would use the slope formula to find the slope the old-fashioned way, which was this, y2 minus y1 over x2 minus x1, in case you forgot what that was. Alright, so you are going to want to, at this time, read example 2 on page 337, and you're going to pause the video while you do that. Okay, welcome back. What we are going to do now is we are going to write the equation of the line with slope negative 2 that passes through the point 3, negative 3. So our general equation, remember, was y minus y sub 1 equals m times parentheses x minus x sub 1. And we are going to just put the x point for my x sub 1, the y point where my y sub 1 is, and our slope is going to go in for m, which gives us y minus a negative 3 do something with that in a second, equals negative 2, parentheses x minus 2. So, we can rewrite y minus 3 as y plus 3 equals negative 2, parentheses x minus 2. And that would be our equation in point slope form. Okay. You'll notice underneath this, the PowerPoint is also giving these things. Okay. So for practice, would you do the following two things? Would you write an equation in point slope form for a line with the given point and slope? And when you're done, come back and check your answer. You might want to pause a minute now. Alright, so welcome back. The answer should be for this first one, y minus 7 equals negative 3, parentheses x minus a negative 1, which would be x plus 1. For our second equation, we would have y minus 8 equals 1/2, parentheses x minus 5. And that would be our two equations or our two answers that you can check. If you're not quite sure how I got that, then double check with Mrs. McDonald or I tomorrow. Okay, final example. Looking at the graph, what if I give you two different points? We're going to write equations for the line in point slope form and in slope intercept form. So first of all, since I'm not given the slope, you have a couple of options here. If you want, you can look and just double check and calculate the rise over the run. If I notice that I am going down 1 and to the right 1, 2, 3, so I can think of that, if I want, as a rise over run or slope of down 1 to the right 3. If that's hard for you, or let's say you don't have a picture of the graph, you can use the slope formula, meaning we subtract the y-coordinate, so 3 minus 4, which I get from the ordered pairs, over 2 minus negative 1. In that case, you notice I get still a negative 1/3. Alright, so just two options for finding the slope there. Now that I have my slope, and I have actually 2 points, you may pick either of the points you want to write it in point slope form. So that means that there could be more than one correct answer in point slope form. I am going to, once again, write y minus y1 equals m times x minus x sub 1. And I am going to choose the point 2, 3. So, I plug the 3 into the y spot, which gives me y minus 3 equals my slope, negative 1/3, x minus 2. Okay, now, to get this into slope-intercept form, okay, so right here what I'm circling right now, this is point slope form. To get this into slope-intercept form, I would simply distribute this. Okay, so I would go, I'm going to do this up here, have y minus 3. But then if I distribute this negative 1/3 to the x, that would be negative 1/3 x. And then negative 1/3 times negative 2, I'll just write that out a second. I'm using the parentheses.